My name is Alejandro Rios. I am 53 years old. I'm originally from Mexico, and I work for Khalifa University of Science and Technology. Our project, called the Seawater Energy and Agriculture System, is to enable the production of sustainable biomass for the production of sustainable aviation fuel, so that the aviation industry is able to grow sustainably. Well, I hope that the judges like the project, and I hope that we are recognized as one of the sustainable projects that exist today. Hello, my name is Alejandro Rios. I'm a professor and chief research scientist at Khalifa University of Science and Technology. And today I'll be talking to you about the seawater energy and agriculture system. We are a consortium that involves several companies. All these companies are world leaders in the field, in their respective fields. So we have among them Etihad Airways, the national airline of the UAE. We have the Boeing company. We have ADNOC through its refining arm. And we have GE, Safran, and Ballard Resources as well. Our system consists essentially of three subsystems. First, we take seawater, ocean water, and we pump it inland, and we use it to feed a farm where we grow fish and shrimp. As these animals grow, they generate waste, and this waste goes into the water. The water needs to be changed frequently, otherwise the animals die. And so what most aquaculture operations in the world do is that they return this water to the ocean untreated. What we do is that we take this water and we use it to feed our second subsystem, which is our halophyte agriculture subsystem. Halophytes are the plants that have their roots in the soil. They're terrestrial plants. They're not algae, not aquatic plants. They're terrestrial plants. They have their roots in the soil, but they have a mechanism to deal with the salt in the water. So we have an agriculture subsystem where we grow an annual plant. This plant is called Salicornia. This plant produces tiny oil seeds that contain about 30% vegetable oil. And so the plants take this water full of waste, in this case full of nutrients, and they absorb these nutrients, which helps them grow. And as they grow, they are cleaning the water. As the water continues its path back to the ocean, we make it pass through our third subsystem, which is a halophyte agroforestry subsystem. So similar to our previous system, what we do is that we cultivate a plant that is a perennial halophyte, which means that it's a tree. And in this region of the world, we're growing what we call the mangrove. Okay, the gray mangrove, it's the only mangrove that grows in this region. And the mangrove has a very extensive root system that allows us to fix carbon into the soil, to clean the water further, and to absorb carbon dioxide from the atmosphere. What we have is our next step in the project is a larger scale facility where we will be creating a commercial farm for producing fish, and we will continue the research and development efforts for the halophyte agriculture and halophyte agroforestry portions of the system. So for a small country such as the UAE to have such a large footprint in terms of aviation, it's extremely important, and we need a way to make sure that the aviation industry grows sustainably. And with that, I thank you.
How is its cost efficiency compared to the conventional one?
So this is a very important point, and one of the biggest problems that biofuels have around the world